Hello, everyone. Thanks for joining. Hi, Naso.
Hello, Dave. Very happy to welcome you at the Knowledge Graph Forum.
Thank you, sir.
Yeah, Semantic is one of our partners, and they're definitely the partner with the best understanding and the highest level of maturity in knowledge management. So Dave and his company, they were living with real knowledge management projects, probably as a quarter century ago. They were doing real knowledge organization systems before this term was coined, 20 years before SCHEMA. And back in the dark ages where even RDF was still not there. But in the last couple of years, 3-4 years, Synaptica made a very, very heavy bet on ontologies and graphs. And I believe that that's the better way and the future of how knowledge management should work, and the kind of representation and tooling should be there to allow for even more advanced knowledge organization systems than those seen in the past. So now we have their graphite controlled vocabulary and taxonomy management environment. We're integrated with GraphDB and essentially offering the best of both worlds, the information scientists and the more technical people like ourselves and the computer science. Dave, the floor is yours.
Thank you, Naso. All right, I'm just gonna share screen and switch to the presentation.
Before you start, let me just remind people that they can post questions in the chat panel. Thank you.
Thank you, Naso. And also, there's going to be a couple of slides where I'm going to invite you to participate in a live poll. So we'll announce those as we get to the slides. So Synaptica's mission, in a nutshell, is we help people to organize, categorize, and discover the enterprise knowledge that they have. And today's talk is going to focus on organize, which is knowledge organization systems. What we now do within RDF graphs. So what is a KOS, which is the central topic NASA invited me to talk to? It is a knowledge organization system. And this is an umbrella term that embraces a lot of other things that people talk about: taxonomies, control vocabularies, classification schemes, thesauri, and ontologies. Traditionally, there's been a way of viewing all these different things as like a scale of complexity. So we start with the simplest, we've got glossaries, and then we add hierarchical structure, and we've got taxonomies, and then we add associative relationships and synonyms, and then we've got thesauri, and then we add more semantic expressiveness, and we've got ontologies. I actually don't like that view. Really think it needs turning on its head. And the way we look at this, and this really is the introduction for the title of this talk, is what is a semantic knowledge organization system? And this slide really is saying, which is our sort of view of this, a semantic knowledge organization system is one that comprises both the schema and the taxonomy. And actually the ontology is just that. The ontology is schema plus taxonomy. So the schema is all of the structural elements, the class types, the property types, the relationship types, and they provide the framework for then creating individual things in that framework. And that thing might be it might be an OWL class or an OWL named individual or a SCOS concept, but they're the individual members that belong inside the ontology and obey the rules of the schema. So this is our kind of definition or attempt to define this field. First live poll, I think Yasin is going to put the first live poll on screen, and I would invite any of you to tell us which you use the most. You probably might use a mix, but do you tend to create vocabularies with OWL or with SCOS? When we are talking to our clients about how to design their semantic schema, we really first just try to get to the bottom of what are they trying to do, because SCHEMA is the right fit in some situations, OWL is the right fit in others. I think the tipping point is to do with inferencing, and OWL is designed ground up to do inferencing. One of the interesting things is you can do some level of inferencing within SCHEMA. So the transitive relationships, SCHEMA broader and SCHEMA narrower, allow you to do inferencing just like you can do through RDFS subclasses of. So, but if you're attempting to build categorical vocabularies, the hierarchical structure might drive content navigation, it might drive topical structures. SCHEMA is almost certainly the better tool to go with. If you are building rigorously set class-subclass structures, OWL is going to be the better one. And of course, we have clients who are building knowledge organization systems that are a hybrid of SCHEMA and OWL, and there's nothing wrong with that either. So what I'm going to do in the main part of the talk is I'm going to talk about how to build semantic KOS. And I'm going to do that through my tool, because this is the tool I have most knowledge of and hands-on. Obviously, there's a variety of cost editing tools in the marketplace. Graphite is what Synaptica builds, and we put this on top of Ontotext GraphDB as the triple store. But in 3 simple steps, building a COS is 1, curating a library of classes and property types and relationship types. 2 is designing the schema, which is basically building KOS schemes by using all the building blocks of these properties and relationship types. And 3 is putting the data in. So that can be done through import from RDF, from CSV, and of course manually and editing the vocabularies that go in. Like anything, it's actually a little bit more involved than that. The flowchart on the left, which I know you can't read, but the slide deck will be posted for you to download after my talk. This is our flowchart as we guide people through if they're starting from scratch, and like, how do you design schemes? What factors do you need to import? You need to be looking at legacy taxonomies and metadata structures, and looking at content and looking at search, and all of these things inform the best design for your ontology and taxonomy schemes. Then the blocks on the right tell us sort of how we go through the process for enterprise taxonomy management. Modeling comes first, then we build collaborative teams, then we set governance rules, then we start developing, and then we get into publication and integrations. And I'm going to walk through some of those things in more detail in the following slides. So first, this next section is about this semantic schema and how we model them. So the first thing that we do in Graphite was we create a space where you can curate namespaces and curate all the predicates that you would use in these namespaces. So on screen, I've got open the SCHEMA namespace and all the properties that I've pulled in from SCHEMA. Also on screen, but not open, is Dublin Core for all of the metadata elements, and so it goes on. So any ontological schema from the outside world that you want to bring in, you bring in. But you're never going to find everything that you need. So you can define your own namespace in this area of the tool, and define all of the specific data properties that you want. And these then become a library. They're like building blocks for constructing a KOS scheme, which is the building in which you can populate all of your concepts and classes. Next is a project, and a project in Graphite is a work area. It's a collaboration space. And what we do with a project is we bring in taxonomy schemes, ontology schemes, and we set permissions. So this is really gives you a view on the world of all of your KOSs, and this particular screen is just the landing page showing the different schemes that we brought into this project. Collections, we base our collections on SCHEMA collections, and this is a super helpful way to take larger taxonomies and larger ontologies and create slices through them. They could be topical slices. They could be, give me this little branch of a tree structure. They could be, I'm going to cherry pick nodes which are going to be used by consuming surface X or Y. Many uses for collections to slice and dice through the vocabulary. What I've got here is just a view where we're visualizing the semantic schema of multiple KOS that have been wired together to form an overall, or as kind of a super KOS. So the dots here, the nodes, these are not concepts or classes. These are entire KOS. Each yellow dot is an entire KOS. And the edges of this graph are the ways that they are wired to themselves and to each other to form an overall semantic schema. And this last screen here is looking at an individual KOS and how we can control that. So what we do there is we pick the properties from our library of namespaces and predicates. We bring in the relationships. We bring in the data properties. We can control cardinality constraints. We can determine, because this tool is very much designed for controlled vocabulary applications, we can go in here and nominate individual data properties to be the unique descriptive field for a concept, and then we'll get descriptor uniqueness enforced. We can specify what types of things are alt labels, set minimum, maximum cardinality on properties, and we can create the wiring diagram of what relationships are allowed. And that's really the last stage of the modeling and schema design, where we build out all of that structure, and that structure becomes the business rules of the system. So a triple store without a control vocabulary interface like Graphite is very permissive. You can write any kind of triple you want. The idea of using a tool like Graphite on top of a tool like GraphDB is to create the business rules interface for doing controlled vocabulary and setting all of the ACLs and permissions to ensure those control vocabularies are built and maintained according to your particular enterprise policies. Let's have a quick look at importing. Obviously, we can import from RDF files. We can also import from simple grids in Excel. So this very simple example is I've got a grid of animals and plants. I've got hierarchy. I've got definitions. I've got synonyms. I've got associative relationships, and they're all in a very simple, eyeball-friendly grid. We can take that grid, bring it into the import tool, and what it will do is it will turn that into an RDF graph based on SCOS, based on OWL, based on whatever business rules you have defined in that scheme administration area we were looking at afterwards. So what we've got here is this is the data that's just come in, being converted into a graph. And if I have a look at the next screen here, I'm showing you an individual concept. This is the canines concept in that hierarchy. So you can see in on screen here in the center section, well, on the left, you can see canines as it is in a tree structure. In the center, we've got the object properties or the relationships. So canines has a broader relationship to animals. It has narrower relationships to different breeds of dog. On the far right, we have the definition field. We've got the synonyms and so forth. And we've got some other workflow control properties there. In the import file, I've got an error. I've got oak trees under cats or felines. Putting it in its right place is as simple as dragging and dropping it in the hierarchy or dragging and dropping it from the discovery pane to the workspace. And you drop it on the predicate that you want to relink it to. And so the editability is a really important part of Graphite. It is here to provide a simple user interface to simplify the whole process of managing control vocabularies. And this screen here is showing you how we can really start exploring the taxonomy, not as a tree structure, but as a giant web of interconnected relationships, of basically the graph. So My concept, carbon dioxide, in a chemistry scheme has relationships out to other KOS. So I've got a KOS in here called GEMET, which is a European Union multilingual environmental sciences thesaurus. I ingested that as an RDF file into graphite. I've also got the UNESCO thesaurus from the United Nations, another reasonably large and multilingual vocabulary. In this graph, my own concepts are shown here in blue, light blue. The GEMET environmental sciences are the yellow nodes, and my UNESCO concepts are shown in pink. But you can see how we can now start really looking at this as a knowledge graph, because I'm going from a chemical concept, carbon dioxide, out to things like climate change mitigation, which then lets me explore relationships to climate change policies and regulations and so forth. So this connectedness is something that we can visualize right within graphite, so that the people building and editing the taxonomies kind of have full sight of all of that connectedness. Collaboration, workflow, and governance is another really important part of doing control vocabulary. As I said earlier, a triple store alone is a very permissive world where there's not a lot of rules. In a control vocabulary world, you really need to control permissions, you need to control workflows, and so we've built a lot of tooling to do that. So starting with permissions control, I'm looking here at a project administration area. We can create role-based user groups. So if I look at this screen as looking at what are the permissions of the editor's user group. And on screen, you can see a lot of little radio buttons where I can hide, view, or allow to be editable down to the individual data property field. So we can, for a user group, we can say they can access this KOS, they're an editor, or they can view it only, or we can fine tune the permissions down at the individual property level to ensure that they are the right permissions. So a good example of this is you might have senior editors with one level of permissions, junior editors with another level of permissions. You could create a user role called subject matter experts, and that role can see the taxonomies but not change anything, except you can allow them, for instance, to make a subject matter expert comment. So that's what this granular permission model allows us to do. By the way, little insider tidbit here. Our entire permissions model was built on RDF star. So when Ontotext was the early adopter of RDF star in GraphDB, we followed suit immediately afterwards, and we re-engineered our whole permission model here to work on RDF star, which gave us quite a bit more flexibility. We also can build workflow and governance controls, and these take a few seconds or perhaps a minute to design a new control and then put it into the user interface. And so this is all the UI driven. So you'll see on screen here, I've got controls like ready for the approver, rejected by the approver, approver comments, subject matter expert comments. These on-screen fields take a minute to design a new one and put it into the scheme. And these then give enterprises the fine control over their community of editors and authors and reviewers and commentators, and who can see what and who can do what. A word on systems integration, and this is going to be the second opportunity to poll. And Naso, may I ask you if you could possibly launch the poll number 1?
Yes, it's launched now.
Thank you very much, Naso. So this slide is talking to, okay, you've built your knowledge organization systems, you've got all this lovely stuff going to be sitting in GraphDB. You edit it through Graphite as a user interface, but how do you connect it to other things? We basically support a full REST-based read and write library. So as anything you can do as an editor, through Graphite, you can make an API call to. So that can be autocomplete search, it can be browse, it can be associative graph browse, it can be, I want to create a new concept, I want to delete a concept. All of that can be supported through REST. We also support Sparkle, but we only support Sparkle in the read mode. And that is because all of that business logic that we've taken great care to design our schema and enforce business rules into the graph through Graphite. If we went in through Sparkle, it's not going to know all of that, all of those business rules or all of those ACLs. So we use REST for read or write, and we use Sparkle for read-only queries into the system. Using this general architecture, we can build out specific things, so specific connectors, let's say, to Confluence or to SharePoint. But really, the REST and Sparkle APIs are the bedrock of any kind of integration with any other system. And in the poll, would love to get your feedback. What kinds of things are you using your control vocabularies or your ontologies, taxonomies with? Which type of content systems, search systems, etc. So please share your thoughts with us. So I'm getting towards the end here, and then we can move into any Q&A. So the in the graph right now, from what we've been reviewing, in the graph are the schema, the ontological schema, the taxonomies that populate that schema and populate the ontology. But that alone, it describes domains of knowledge for the enterprise, but it is not an enterprise knowledge graph. An enterprise knowledge graph requires you to also bring into the graph reference data or content metadata. When the graph is content aware, it has the ontology in it and it is content aware, then you have a full-fledged knowledge graph, because then you can do analytics over both the data, the reference data, the content metadata, and you can do it through the lens of the ontology and the taxonomy. And this is why Synaptica forged a very close alliance with Ontotext, because an enterprise knowledge graph is really two disciplines coming together. It's information science, which Synaptica has been doing now for 26 years, and it's data science, which Ontotext has been doing for over 20 years. So we really we're molding Graphite and GraphDB together to really bring the best of these two worlds. It's computer science and data science, which are the expertise of Ontotext, and information science, which is Synaptica's expertise, and building tooling that's deeply integrated with that. So Graphite and GraphDB is our attempt to provide unified tooling for doing semantic knowledge organization systems, and to do them as an RDF graph, and specifically to do it in GraphDB, because that's the only graph database that we elected to work with as the best in breed for RDF graph databases. And I think that's going to, yeah, I'm just, this final slide is just a little bit more on all of the good stuff you can do once you've got your data into GraphDB with your control vocabularies and other metadata. You've got the tooling to do your analytics, NLP, all sorts of cool stuff that is supported from the graph database. And that is where I'll stop. Thank you very much. And Naso, over to you if there's any questions.
Yeah, hello. Yes, there are questions. First, then we got the results from the polls. You definitely had the most, with 2 polls, you had the most interactive presentation so far at the Knowledge Graph Forum. The first one, which was, do you primarily use SCHEMA or OWL-based vocabularies? Well, we get 20 votes for OWL and 15 for SCHEMA. So it seems the audience here is geared a bit more towards OWL, but fair representation of SCHEMA people also. And then for the first poll, yeah, you can comment the results if you want to. Quite a variety of different systems.
Mm-hmm. Yeah, I think that's looking a bit like what I would expect. So mainly it's content systems, search metadata. So that's, and then some smaller groups for things like PIM and process management. But this is really good. Thank you. Thank you to anyone who responded. That's very helpful.
Yeah, Dave, you can stop sharing your screen so that we can just see the cameras. Okay, there is a question. What makes GraphDB better than others, say Neo4j or Neptune?
Well, so I won't comment on anybody else's brand, but I would say this. We started building control vocabulary management tools a few years ago on property graph rather than RDF graph. Spent quite a bit of money doing it, and then I realized that we're back to the core, and that if you're going to do control vocabulary management, it really has to be on an RDF graph. So from our perspective, doing it as RDF, doing it as linked data triples natively in the database as linked data triples, rather than just converting IO to RDF, is essential. And we took that decision. We threw away money we'd spent developing on a property graph, started again on a graph. Now, why GraphDB? From my perspective, GraphDB had solved some of the performance search requirements that the graph databases struggled with. So, a SQL Server database is brilliant indexing tables and providing really high-speed responsiveness. A graph database, but it can't handle certain kinds of pattern queries. Graph database, great with pattern-based queries, but not particularly good on search. Ontotext has spent a lot of time developing a certain high-performance search on top of the graph. That was one of the reasons that we wanted to work with them. The other reason is just following them over the years. Genuinely think they are a thought leader. They are really creative. They adopt things like RDF star, first adopter of RDF star that I know of, and that influenced us to say we really want to work with Ontotext and GraphDB.
Okay, yeah, thank you for the good words. Is there is a question from Vivian Chang. Is there a vision to integrate a vendor tool of knowledge graph with traditional enterprise data architecture tool, say Irwin or ER Studio or something like that?
That's not on our roadmap. We have encountered the Irwin before, and people have shared models with us that they've developed in Irwin, and we've talked about it. So so I can say, is there a fit? There is a fit. It's not in our roadmap for the immediate future, but it may get on the roadmap.
Good. There is another question from Maxim Greenman. What are the go-to tools and ecosystems to use for extracting content from text into various useful ontologies and importing into RDF? So the text analysis topic is open.
Text analysis. Okay, so I actually had a whole segment of slides on text analytics that I knew I wasn't going to have time to address and talk to today, but we are working very closely with Ontotext on Ontotext have text analytics tools. Some of them are going into into the baseline GraphDB product for the extraction of concepts, the extraction of named entities, the extraction of facts and relationships. So we are going to be working with Ontotext text analytics tools to basically bridge the gap between how they work and how the taxonomy ontology piece works. But the whole goal there, and this is something that Ontotext is doing very well with GraphDB, is you can perform your analytics over content. You can look for the entities and all of the relationships, and those annotations that extract the data can then go back into the graph.
Thank you. Thank you, Dave. We have to switch to the next session. You can reach out to Dave at the booth. Thank you.
Thank you. Bye-bye.